All right, so let's just talk about data. So we said statistics is about making conclusions from limited data. So let's talk about data itself, okay? So data, we can think of data as information, and usually it's organized somehow. Okay, and as far as data goes, there are we have two types of variables, okay? So these are bits of information that we can collect about people, okay? Or things, whatever it is that we're studying. We have two types of variables. We've got numeric variables, which tell us how much or how many. And we also have categorical variables, which tell us what type or what kind. Okay, and so you can think of storing our data in a data table. Okay. In the data table, okay, each row is an observation. Okay, so what we have is, if you have a sample, okay, we've taken a sample, we will say the sample size, we denote the sample size with a letter. We'll say n is the number of observations that we have in our sample. N is our sample size. In the data table, each row is an observation. So, you know, n is our sample size. And so what this means is that in our data table, we have one row for each observation. We will have n rows, okay? N rows in our data table, because you have one row for each observation. Does that make sense to everybody? Okay. And in the data table, each column is a variable. Okay, so we can create a data table. This is a table of crash test results. Okay, and so what we have is each row represents a crash test, okay? And these are the columns that we've taken. We've got the make, the model, the number of doors, the weight, and the crash injury crash rating, I guess. Okay, so each row is a crash result. So we have something like the Acura Integra, which has 2 doors, weighs 2,350 pounds, and had a crash rating of 599. I don't know if that's good or bad. Okay. And then, you know, maybe we look at the Ford Taurus, which has 4 doors, weighs 2,390 pounds, and has a crash rating of 480. Okay, etc., etc., etc. Okay. So here I've only written down 2 crash test results, but this is what we have. Okay, so if we ran 10 crash test results, we would have 10 rows. Okay, and how many variables do we have? 5, right? Okay, and which ones are categorical and which ones are numeric? Yeah, so make and model, these are categorical, right? Categorical, categorical. And this is numeric, numeric, and this is also numeric. Okay, because these tell us how many. Now, as far as doors go, we could have changed it. Instead of doors, it could have been coupe or sedan, and then suddenly it's now categorical. Okay. Now, sometimes we have variables that are like that. We could ask how many doors does your vehicle have? That's a numeric question because you're going to tell me you have 2 doors or you've got 4 doors or something like that. Or we could say, you know, what's the body type of your vehicle, and you can tell me it's a coupe or sedan. And in general, sedans mean you have 4 doors, and in general, coupes mean you have 2 doors. So sometimes we have things like that. Sometimes, you know, I could ask what is your age, okay? And generally, when someone asks, what's your age, you reply back, I am this many years old, okay? And that would be a numeric question, okay? However, if you are a polling organization, you don't actually want the number. You want to say, are you in the 18 to 25 demographic? Are you in the 25 to 39 demographic, or the 40 to whatever demographic, okay? So in that case, we've turned age into a categorical variable. So it depends how things are recorded, but the essential question at the base is how much or how many goes to numeric variables, what type or what kind fits in with categorical variables. Okay, this is this is the data table. If we think we can summarize our data tables, okay, so we have summary tables, okay, to summary tables to basically provide a summary of our data table. So you could imagine we could create a data table for an entire classroom, right? And we would have 1 row for every student. So approximately how many rows would we have? Approximately 80, okay, so this would be approximately 80 rows. And we could gather all sorts of information, your name, your age, your gender, all sorts of stuff. Okay, now somebody might not want to look at a big table with 80 rows in it, okay? They might just want a summary. And so we could create a summary table for, this will be a summary table for gender. and it's going to be something like this. Okay, so we're going to have male and female, and well, this kind of puts the assumption that there's only two genders listed, but and then we will have what we call a count or a frequency. All right, and so I don't know, I'm going to make up numbers. Something like that. Okay, and so this is called a frequency table. Okay, we could add another column called relative frequency, which basically just turns it into our counts into proportions here. So how do I turn this into a proportion? So or a percentage. So if I'm going to have 100% at the bottom, what do? I do 36 divided by 80. Okay, and I would get what? 45%, right? So you can do 36 divided by 80. And it would give you 0.45, and we know that's 45%. And so over here, if everything has to add up to 100%, we know this is going to be 55%. So this is called the relative frequency table. So if you have this column, it might be a frequency table, or with the other thing, we can call it a relative frequency table. Okay. This is still a summary table. It's still a summary table. It's a summary table because we do not have 80 rows, okay? What we've done, we only have 2 rows, or maybe 3 rows if you count the total row, I guess. So we've taken the data table, which has 1 row for every student and has 80 rows, and we've shrunk it down to just 2 rows. And this is a summary table, okay? And so when it's a summary table for this, we call it a frequency table, or a relative frequency table if we've got this. Okay, so here's just a quick question. What kind of variable did we summarize here? Did we summarize a numeric variable or a categorical variable? Okay, we've summarized a categorical variable, okay? Because what's the variable that we're looking at? Gender, okay? Male or female, that's a category, okay? So we have summarized a categorical variable. Okay, so gender is categorical. So, yes, you have numbers here. This is a count of how many males you have. This is a count of how many females you have, so those are numbers. However, if you think about what is the variable that's being summarized, it's a categorical variable. So don't just think, oh, I see numbers, it must be numeric. You have to think, what am I actually summarizing here? Or what is the variable data that I'm looking at?
So if we would have done, like, let's say age, why is it an age range that would still be categorical though? Yeah,
if age group, right? Okay. If it's, well, I guess it depends how you've how you've recorded age. Okay, if you're splitting it into 18 to 25, yeah, then that becomes a categorical thing. Okay, if you're trying to calculate something like just the average age or something where you're looking at individual ages, then it would be numeric. Yeah. Question? Yes.
If we substituted the gender with male, female into a numeric analog, like category 1, category 2,
okay,
would it still be a categorical?
Okay, so this is a tricky thing. So this often happens in computers. We often turn our categorical variables into ones and zeros. So we'll say, we'll say male 1, female will be equal to 0 or something like this this just assumes you can either, you're only going to be recording zeros and ones in that thing, and maybe that's the case. Essentially, at the heart with a numeric variable, you want to be able to ask, you know, if this has this value and this has a different value, can you make a comparison between those two numeric values? And if the answer is yes, then it's a numeric value. If the answer is no, then it's probably still categorical, okay? So it could be, you know, how many Y chromosomes does someone have, okay? Then, yeah, it's kind of like a numeric question to a categorical thing where you're either going to have 1 or 0. But if so if we say, like, you know, what is your area code? Okay, what's the area code on your phone number? You're going to tell me something like 310 or 213 or, you know, 562 or 818 or something like that. Okay, there's no numeric value to your area code. It doesn't make sense to say, oh, I have 213 more area code than you. Okay, or, you know, oh, this guy, he has 506 more area code than me. It doesn't make sense to make those types of comparisons. So area code would be a categorical thing, even though you're getting some kind of number there. Okay, so area code would not be a numeric variable. It's categorical because it does not make sense to make those numeric comparisons. You know, if we're talking about siblings, sure, you can say he has 2 more siblings than I do. That comparison makes sense. This person is 3 inches shorter than I am. Comparison makes sense. Yeah.
So can you say, is it safe to say categorical has no value in comparison with one another, and numeric usually has a value in comparison?
Right. Yeah, you can't. Yeah. Well, I mean, if you're trying to do a comparison between male and female, you can't say, like, he has more male than you know. It just. Yeah, there's not. It's not. You can't do this numerical comparison. You can't say more or less. You know, like if you're talking about a vehicle and the paint color, you can't say, like, I don't know how you would compare red versus blue versus black versus white or something. You know, it's like you'd have to turn it into some kind of number, and now you're talking about hue values and. Okay, so it's just not going to work out. Okay, so we've got this. Let's talk about gathering data in via observational studies or experiments. Okay, so with an observational study, okay, we observe. Okay, we try not to interfere with the people or things that we are studying. So whatever it is that we're studying. Okay, so we try not to interfere with these people that we're studying, or if we're studying plants or whatever, we try not to interfere with them other than taking measurements. Okay. And that's that. Okay. As far as experiments go, okay, we often try to control as many aspects of variation as possible. Okay. Ideally, we can create identical situations for everyone. All right, yeah. For everyone or everything, okay? With the exception of our treatment variable. Okay, and so, you know, for example, let's say we want to know, does a certain medication help reduce anxiety? Okay, you know, like as an example. Or we'll just say, does a certain medication will do reduce blood pressure? Okay. Well, if we think about it, there are many things that could go into affecting a person's blood pressure. Okay. Their age, their gender, their race, their diet, their exercise amount, their work activity. There's lots of things that could go into determining someone's blood pressure. Okay. Okay, and so what you don't want to do is you don't want to give all of the men in your study the medication and all of the women in the study the placebo. Okay, so placebo is the fake medication that doesn't actually do anything, but because our brains can psych ourselves out, we give people placebos. Okay, so you don't want to give all the men the real medication and all the women placebo, because at the end of that study, let's say you find there is a difference between the medication and the placebo. In that case, you don't know if the difference is because of the medication or if the difference is because this group was men and this group was women. Okay, so what you want to do is you want to make your two groups as identical as possible. You want to try to account for all of these different things. Ideally, you would give them all the same diet. Ideally, you would put them all on the same exercise regimen. Ideally, you would put them all in the same life scenarios that have the same amount of stress or whatever. But of course, that's not possible. But ideally, we could control everything and make our two groups as identical as possible. And then the only difference would be this group gets the drug, this group gets the placebo. And then at the end of our study, if we see there's a difference between this group and this group, then we know that difference can be attributed to the drug versus placebo and not any of these other aspects that play a role. Okay? So let me write kind of what I just said down. So lots of different things can affect a person's blood pressure. Ideally, everyone in the study has the same conditions. Okay, one group gets the drug, one group gets placebo. Any difference at the end between groups any difference between the groups at the end can be attributed to the drug versus placebo. Whereas if you didn't set up the study or the experiment in this controlled fashion, you might find that you're not sure if it's because of the drug or if it's because of many of the other aspects. Okay. Do you have a question? You're okay? Yeah. Okay. You just looked a little concerned there. All right. Are we good on this this aspect here? Okay. So there are a few kind of terms that I will leave up to you in as far as the reading goes. So you should learn response variable. So these are terms: response variable, treatment variable. So the response variable is the thing that we're interested in. The treatment variable is the thing that we kind of change from one group to the other. Okay? And you need to learn confounding variable. I'm sorry? So confounding variable, that would be if you made the bad mistake of doing the group that gets the drug is all men and the group that gets the placebo is all women, then the drug and the gender would be confounded because you can't tell the difference between, is it because of the gender or is it because of the drug that we're seeing a difference? Okay, and so the key difference is that at the end of the day, with observational studies, at best, we can say that there's an association between variables or effects. Okay. So with the observational study, you cannot say one causes the other. You can just say that there's an association, that increased amounts of stress are associated with increased risk of heart failure or something like that. Okay, but it's hard to say that stress is the cause behind heart failure. Okay, we can just say increased amounts of stress is associated with increased risk of heart failure, but we cannot say that stress is the thing that causes the heart failure. As far as we know, people who experience higher stress might also be in, different situations that pose a greater risk for heart failure, things like that. Okay, it would not be possible to do an experiment or an ethical experiment where we are purposely increasing someone's stress level and recording if they have a heart failure episode. Okay, it's not ethically possible to do something like that. So at best we can just say that there's an association, but we can't say one causes the other. Yes, question.
How can a theory be sure?
That's life. We can't know for sure. Okay. Yeah. All we can say is that there's an associated risk. Okay. We can say it. That's all we can say. We cannot say with definitive knowledge that this thing is causing this thing. All we can say is that there's an associated risk, and you just take that knowledge and say, well, maybe I want to reduce this thing. Yeah, question.
So the correlation is not the causation?
Yeah, that's a nice another way of saying it. Correlation is not the same as causation, although correlation has a very specific meaning in statistics, so I often will say association is not the same as causation, but it shows up later on in chapter 4.
So a conclusion does not have to be definitive, it could just be,
Okay, so a conclusion does not have to be what we call causal. It does not have to say this thing causes this thing. We can say these two things happen together, and everywhere we've looked, they've happened together, but we cannot say that one causes the other or the other causes the other, okay? So with an experiment, though, you know, if the data supports it, supports a conclusion, supports the idea, we can say one thing causes another thing. Okay, so causal relationship. Okay, so we can say, in our experiment, we made these two groups identical. Everything about these two groups were identical, except this group got medication and this group got placebo, and at the end, we found this group improved, whatever, you know, their blood pressure, their high blood pressure went down. And this group that got placebo, their high blood pressure remained the same. And because everything else was the same, we can therefore attribute this difference to the fact that they got the medication and they got the placebo, okay? So with an experiment, well-designed one, you can say that, okay? But again, not all experiments are ethically possible or even practically possible, okay? Okay, we can't ask, does, you know, there's a lot of questions. We want to know, is it safe to take this medication during pregnancy? Doctors want to know these things, okay? But we cannot have an ethical experiment where we're like, oh, congratulations on your pregnancy. Sign up for my experiment and we're going to give you drugs and we'll see if it causes any problems with your unborn child. We can't do that, okay? So, you know, if in some universe there was no ethics, we could probably make lots of advances in this field of science, but we are not bad people, so we're not going to do stuff like that, okay? So yeah, but you know, so basically, right now, if you get pregnant, or you know, if someone you love gets pregnant, you basically have to say, okay, avoid every possible medication because we have no idea what effect this has, right? And you have to kind of live in this little bubble that says like, oh, okay, well, I can't eat anything like that, whatever, you know. So that, yeah, okay. So anyway, parenthood is excellent if you want to become a parent. So it's worth the trouble. All right, let's move on into chapter 2, and we're going to talk about displaying categorical data. Okay, so I'm going to skip ahead a little bit into displaying categorical data, and then we'll talk about, next week we'll go back and just talk about displaying numeric data. Displaying categorical data, and we'll also, I guess, summarize categorical data. Okay, so we've already talked about summarizing categorical data with a table, and what was that called? The frequency table, right? So we can summarize categorical data with the frequency table, all right? And so earlier we showed this, something like this, that said like male and female, and the frequency was, I don't know, I just made 3644 out of 80 or something like that, okay? We could also further split this into a, we can create something called a two-way table. And so we could say maybe we have two categorical variables. And so here we will say gender, so male or female. And then we will say hand dominance, okay? So are you right-handed or left-handed? Okay. And so here we will create a two-way table that looks like this. We will have right, left, male, female, okay. All right, so as far as totals go, our grand total, if we assume this represents our classroom or something, we will say there's a total of 80 people, okay. What number goes here? Total number of males that we have? 36, right? Okay, and that means 44 must go here, okay. And now I'm just going to make up a number. We'll say 5 left-handed males. Okay, so that means how many are right-handed males? 31, okay. I'm going to just, we'll make up another number here and we'll say 6. Okay, so that means how many go here? 38, good. Okay, and so here we will have 69 and 11. Okay, good. So now I can ask something like, what percentage of people are right-handed? And you would tell me, what is the fraction that we would have to do? 69 divided by 80, and so this is going to be some 86.25%. Okay? Or I could ask, what percentage of females are left-handed? Okay, and what is the fraction I would do here? So what percentage of females are left-handed? So how many? This would be 6 divided by 44, right? What percentage of females, so let me just kind of, what percentage of females are left-handed? So in the numerator we would have 6, and in the denominator we would have 44, and so our answer there would be 0.136 or 13 point, I don't know, 636, so 64%. Yeah, 636 or something. So if I round off to 2 places after this decimal here, okay. Let me write up over here, and I'm going to just write what percentage of left-handed people are female. Okay, And what is the, what fraction would I have to do here to get the answer? 6 divided by 11, right? So we have 54.54%. Okay, I just want to make sure everyone's okay, or if there's any questions here. Because these two things sound similar, but they are very distinctly different as well, okay? Because here the question, the key part is what percentage of this group are this group, okay? And so over here we have what percentage of females are left-handed, and over here we said what percentage of left-handed people are female. And those are, they sound similar, but they are very different, right? Over here my answer is about a little over half are female, and over here about 14% are left-handed, okay? So please make sure you understand this, okay? What kind of data have I summarized in this table here? Categorical data. Okay, we've summarized categorical data. So even though we're getting numbers and we're getting counts here, the actual variables themselves are categorical. Okay? Categoricals tell us what type or what kind. Okay. Okay, let's talk about displaying our categorical data. With a bar chart. Okay, and so here I'm going to just take our simple summary table that said male 36, female 44. Okay, and so all we would do for making a bar chart, on your vertical axis you would need some kind of numeric guide to show you something. So this would be our frequency up over here, and down over here we would have our category, and so I would have a category for male and a bar or a category for female, and we would draw a bar that goes up to 36 and a bar that goes up to something like here. $44. Okay, and then yeah, if we're feeling fancy, we can color this in. Oh, I don't know what happened to. Oh, here it is. Oh, hate when that happens. Ah, it doesn't matter. No, I'm gonna do it. Okay, yay, all right. So there you go. You can also make a pie chart, but I don't like pie charts. Oh, it's the wrong tool. So pie chart, you know, this is supposed to be a circle, and then you need to like create some kind of angle, and you'd have to say, okay, well, 36 out of 88, what was that? That was 45%. 36 divided by 80 was 45, and you'd say 45 times 360, so I would need an angle of 162 degrees. This is not this is not the thing I want, and so I could bring this over here, and what is the angle is, what is this, 90, 0. Okay, well, now I have to do math. What is this stupid nonsense? Okay. All right.
Pie charts?
Yeah, well, okay, so this is, and this is assuming a good circle here, which it's not. And then, so you'd say this is male and this is female. This is not the reason why I hate pie charts. The reason why I don't like pie charts is, okay, so let's come up with some other scenario where, I don't know, we're talking about the color of your car or something, and let's say people have white cars and silver cars and, I don't know, black cars and, I don't know, red cars, all right? And then and we'll say other. Okay, just because, but these are probably the most common colors of vehicles right now or something. But this is now too many. I regret my decision of an example. Okay, so this is vehicle color. And we got frequency. All right, so I'm just gonna make up numbers here. Okay, so we got 20, 22, 21, 15, and 10, okay? So if you have something like this, all right, I'm gonna just write white, silver, black, red, and other, okay. So let's just pretend we're, this is a bad, okay, so I've got a break over here. This is bad design here, but we got 20, or I'll do it right. I can't. I was gonna be like just cheap, but okay. So we're gonna have a bar at 20, and then a bar that's 22, something like that, and then a bar that's 21, and then a bar that's 15, and a bar that's 10, or something like that. Okay, now, for whatever reason, our eyes have really developed to a point where these bars are very close, but even from a distance, you can kind of tell that this one's the tallest, right? That this is the 22, this is 21, and this is 20. Like, somehow our eyes can really tell that these are that they're close, but this one's a little bit taller than this one, and this one's a little bit taller than this, and things like that. Our eyes can kind of see that, okay? If you have a pie chart, you'd get like angles that are like something like this, and then I'm gonna ask you like, which is the biggest angle? And like, we're terrible at distinguishing, like, is this one bigger than this one? Who knows, right? Like, or like, you're like looking at the piece of pizza and you're like, oh, unless without really cheating, it's hard to tell just from angle alone which slice of pizza is the biggest, okay? Because we're not so good at that. So, but as far as bars go, our eyes, I don't know, have come to a point where we can distinguish things from a distance. We can really tell differences in height, okay? Like, you can, and you walk around and you can look at someone and say, oh, that man is this tall, and something like that, Like, we've gotten really good at distinguishing heights. Angles, not so much. Okay, so bar charts, they're the way to go. What kind of data is this? Categorical. Good. Okay. Next week we'll see some numeric data. Let's talk about variation in our bar charts. Okay. So variation is the concept of, are most of the things quite similar to each other, or are things quite different from one another? Okay. So if you have high variation, things are quite similar. I'm sorry, high variation means things are quite different, and little variation means things are quite similar to each other. High variation means the people or the things that you are studying, okay? The things studied are quite different from each other. Okay, and then over here we got low variation. Okay, and this would mean the people or things are quite similar to each other. Okay, so this is the concept of variation. And so let's talk about variation. So remember, we're talking about variation of the people or things that we're studying, okay? So bar charts are for categorical data. Okay, and then so this will be group 1, and this will be group 2. Okay, and let's just say these are I don't know, job types. So we've got I don't know, industrial, service, I don't know, tech, and health. Okay, I'm just making things up here, all right? I have no idea what I'm talking about. Okay, does group 1 or group 2 exhibit more variation? Group 1 or group 2 exhibit more variation? Who thinks group 1 has more variation? Okay, group 2? Okay, all right, well, let's think about this. All right, okay. The people or the things studied are quite different from each other, or the people or things studied are quite similar to each other, okay? The answer is group 1 has way more variation, okay? More variation. Now why? You'd be like, oh, these bars all look like they're the same height. That doesn't look like variation, okay? I'm assuming that's your line of thinking there, okay? We're not looking at the height of the bars is not of what's interest to us. The height of the underlying variable, what job type do you have, that is the thing that's of interest to us, okay? So if you go to, if I just rename this from group 1 to call this city 1 and city 2, okay? If you go to city 2, pretty much every single person you meet has an industrial type job. You're not going to meet people with different types of jobs. You're going to be like, oh, I wish I need to see a doctor. There's only like one doctor in town or 2 doctors in town, okay? There's no variation there's not much variation. Everybody has the same job type here, okay? You go to city 1, you've got some people in industrial, some people in service, some people in tech, some people in health. You've got a large variety or variation of occupations and job types, okay? So it's misleading to just look at these. Well, it's not the right line of thinking to say, oh, these bars are all about the same height, no variation. This is actually, when the bars of the different categories are all around the same height, that's a sign of good variation, okay? You know, and whatever categorical variable that we're thinking of, if we're talking about race or something like that, okay, or ethnicity, Los Angeles, California, probably looks more like this. You've got a large variety of ethnicities and races represented in California. If we were to go to China, okay, you would not have the same kind of diversity, okay? Most people would be Chinese in China, okay? So as far as, ethnic diversity there, or variation, it would be something, okay? Something like that. So that is, seeing variation in bar charts. If you have one category that's like very dominant in a bar chart, then that indicates less variation, okay? So, in industry, a lot of people decry things like this, okay? They say, if this happens in an industry, that it's called a monopoly, right? So so if you think back 20 years, Microsoft had a huge control over the personal computing market, okay? And so if you ask, what kind of computer do you have? Almost everyone said, I have a Windows-based computer, all right? Today you have a lot more balance between Windows and Apple, okay? And Linux is, still far behind, or I don't know who else is a player. Chrome OS is now like appearing, but they're still far behind. But it's a much different scene today than it was 20 years ago and things like that, okay? But as far as email goes, we're seeing a lot less diversity now than when the internet was first born. I think when the internet came about, you had everybody had all sorts of crazy email addresses, right? So and so at there's CompuServe and AOL, and those are the big players, and PacBell and rr.ca. whatever, and blah 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 blah. And today, if you say anything other than Gmail or Yahoo or some Hotmail or Microsoft-based thing, people would be like, what kind of email is this, right? Maybe if you have a company and you have a company-based email, but your personal email, there's really only one major player of Gmail, and then everyone else, you're get with it. You're still using AOL? What is this, right? My apologies to anyone who has AOL, right? So, but there are, well, it is true, yeah, anyway, so I'm going to get myself in trouble here. Okay, I think that's all I want to talk about for today. We'll end there. Take a look at your homework and your practice quiz. We will have a quiz starting at 7 o'clock next week, so please arrive here on time. And looking forward to a great quarter with you guys. Yeah.